I'm Mohammad Quraishi. I'm a senior principal technologist at Cigna.
My name is Shmain. I'm a principal solutions architect at Cloudera. So I've been around the industry for about 15 plus years, mostly finance and healthcare. I spent a good portion of last year on the ground with these guys here, helping them develop their next generation system. Fun fact, I don't know how it's relevant here, but actually I was one of the youngest MBA graduates at Stern School of Business. And Mohammed?
And I am a computer science engineer from University of Connecticut, go Huskies. And I do a lot of fun things, but that's not why you're here. So the way we divided this talk is to just go over how we started. We'll show you our architecture and how we landed with real-time analytics at Cigna, show you a little bit of that and go over some of that architecture. We can get as technical as you want. We'll leave some time at the end for questions. And then, let's just dive into it, right? So at Cigna, when you have a already mature data warehouse, data mart type of an environment going, how do you bring in something like a big data platform and tell them things will be better, or even better than they were before? But our goal really was to just sort of deploy the platform and make sure people are still calm, they're going about their business. In this picture, there's actually 3 elephants. And people don't know that they're now using the same techniques, but on a platform that can scale for them, that will allow them to do analytics at a much larger scale. So, this is just a stock picture from the internet, but if you think about hub and spoke architectures, that's pretty much what most companies would do is they have a lot of data, they do some ETL, bring it into a warehouse, assign a bunch of marts, specialized marts to it, and people will do their applications or reporting code off of it. For us, really, the vision was the most important aspect of this when we wanted to deploy the Hadoop platform or the big data platform at Cigna. Even though, the big things, we've all heard about the 3 Vs, we wanted to deal with data that comes in very large volumes. It's in many different shapes and sizes, unstructured, structured, and it arrives in different speeds. Some of it is batch, some of it is coming in real time. What we wanted to do was emphasize the fact that you can do what you do today, which is 80% of your work is curating data, giving it structure, and then reporting off of it or building applications off of it. What we wanted to say is you can now do that at scale, and you can do terabytes of data curation, your descriptive type of work, but you can also do predictive modeling, so things like sentiment analysis on not just 2 years worth of data, but 20 years, 10 years worth of data, whatever legal allows us to do with keeping historical data. And when you're doing predictive analytics, and you're doing sentiment analysis, and you're trying to figure out if people are taking the right medication over a 10-year period of time, and how their health either gets better or worse, you can now also do prescriptive analytics and provide suggestions and say that if you followed path A, these are the benefits. Followed path B, you get some other benefits. But what's important here is you're doing it at scale. So your models are going to be probably more accurate, and people are going to have a great time trying to figure out what other insights live in that large environment. IT barriers, one of the biggest goals that we had was we're going to remove IT barriers, so you don't have to contact an IT guy if you wanted to move a data. We were going to put the data in a lake, and then we were going to just give you access to it so you can explore. So I don't have to repeat this. You've probably heard this many times. It is cost per terabyte. The point is very, the environment is cheaply, and you can stand it up quite effectively and smoothly and with ease, and that's what we did. But the biggest advantage that we wanted to provide was you can now do iterative analytics at scale, fail fast, right? So whereas some algorithms you were running potentially took days, you can now do them in minutes and hours. So that was our largest pitch is you can do fail fast, iterative analytics, and keep improving your models. And you don't have to throw away your data anymore, right? So you can keep your data around. You don't have to keep sampling. Just use the data that you have and run your algorithms on it. So where we started with this was, what we wanted to do was pick a vendor that employed Apache's the open source Apache Hadoop environment, but the distributor actually also was one of the contributors to the open source space. And they dealt with, what we wanted to do was make sure that as the big data space was evolving, which was very fast, evolving quite fast 3.5 years ago, and still continues to do that, we wanted to pick a vendor that would keep current with times. And so vendor lock-in was also a very important factor for us. We wanted to be able to switch. And when we followed some of these things, we landed with Cloudera. And I'll turn it over to Jeff so he can talk about some of the things.
So you guys, a lot of you are probably familiar with Hadoop ecosystem. There are way too many animals to list. So how do you make sense of all of this? So at Cloudera, with our enterprise data hub, we actually split it up into different horizontal layers. So the bottom is obviously storage. That's where you store all of your data. In the middle is a resource management framework. And the top layer is our execution framework. Those are the execution engines and the APIs, how you interact with your data. And obviously, to bring it all to a distributed, very scalable system, you need a management layer. And a company like Cigna, you also need a very strong security capability. So it's not just dumping your data on a bunch of servers. You need to make sure people have proper access, people who are not required to see it will not see it, and you follow all the appropriate laws. So the way we break it up, now zooming in a little bit, for the storage layer, we use HDFS, which is a highly distributed file system, very scalable. We kind of think of HBase as a different storage engine, although technically it stores files on HDFS. It's actually really a key value store. And we're always coming up with new things. We've recently released Kudu, which is our beta product, which is really a columnar storage at scale as well. And it will try to bridge the gap between fast scans of HDFS and the fast key lookups with HBase. We have standardized on Yarn as a resource management framework. The reason is because it's a very strong community support for it, many contributors, and it's growing faster than other resource management frameworks, perhaps. When it comes to execution engines and APIs, there are different ways you can interact with the data. One way is traditional MapReduce jobs, which was there from the beginning, so most of you are probably familiar with that framework and how the batching works there. The next one is NPP, which is our Impala product. This is a massively parallel processing SQL engine on top of Hadoop. We also have Search, which gives you a reverse indexing functionality and allows you to Google your data effectively. And finally, Spark. So I expanded a little bit on Spark here. And the reason I've done so is because it's a relatively new framework. It's been developed and released to Apache in 2010. Cloudera has included it into its distribution since 2013. And the reason it's important is it's a next generation general purpose processing engine, and it gives you a very nice APIs how to interact with your data. But in addition to that, it gives you all of those different frameworks, some like Spark Streaming, which allows you to do streaming applications. Spark SQL allows you to run SQL on Hadoop as well. So it's a little bit of a competitor to Impala, but I'll expand how they fit together. GraphX allows you capability to navigate the graphs on Hadoop. And also, it is a batch system as well. So you have batch APIs, which kind of will be replacing MapReduce going forward. So how does this all intertwine together? So we think of MapReduce as still a workhorse in the industry. So for very IO-heavy workloads, you will still use MapReduce. And by the way, when Cigna started 3 years ago, they started with MapReduce because not many things were available at that time yet. So Cloudera is not dropping the support for it just because there's something cool that came out. But we do think of Spark as a next generation processing framework, general processing framework. So that going forward, more and more workloads are being replaced by Spark. And in addition to that, I mentioned Spark doesn't just come with batch. Spark comes with a bunch of other libraries like Spark SQL, GraphX, and all those nice things. So that project is growing extremely fast pace, and it's important that we continue investing into that. In addition to that, we have a free-form search with Solr. And like I mentioned, it's a reverse indexing engine, which allows you to do free-form queries. Similar, like everybody knows how to Google your data. So you do how to Google on the internet. Same things you can do with Solr on your data. And finally, I mentioned NPP engine Impala, which is a SQL engine on Hadoop. It's a specialized SQL engine. So while it does have some overlapping functionality with Spark SQL, we believe it's a much faster system. So if you have a lot of BI tools that interact with the data, like Tableau, MicroStrategy, and all those things, Impala will still be your best bet to interact with that type of data. So again, like we're talking about Cigna here, which is a healthcare industry. So how do you actually secure this whole infrastructure? That's another capability that you can kind of get when you bring in a vendor. So with Cigna, there are 4 layers of security that you have to keep in mind. Authentication, authorization, encryption, and auditing. Cigna has all bells and whistles enabled there. So let's start with authentication. The way authentication works in Cigna, they have their own KDC, which is the Kerberos Distribution Center, a key distribution center, which has a one-way trust from Cigna's Active Directory. So when users need to access the data, nothing needs to happen in Hadoop. They're automatically authenticated by the existing framework of Active Directory. And the same Active Directory also drives all of the front ends when you access the data, Hue, Cloudera Manager, things like Tableau as well. So basically, all authentication happens through existing infrastructure of Cigna Active Directory. But now that you have got through perimeter, so perimeter is one thing. So now that you've got through perimeter, there's a next level of security that you need to be able to enable, and that's authorizations. Authorizations allow you to segregate the data at more granular level, and we accomplish it with a product called Sentry. So if I'm a business analyst dealing with claims, I don't really need to look at information security data. So truly in Cigna, this is a multi-tenant cluster. So the ability to segregate tenants based on security policies is very, very important. The next level is encryption. Encryption actually breaks up into two different types of encryption: encryption in flight and encryption at rest. In-flight encryption is all the front ends, when you connect to them, all the communications have to be secure, as well as many of you may know, Hadoop has many, many different processes that communicate with each other. So all of that communication has to be encrypted as well. Cigna has that enabled, as well as encryption at rest. So encryption at rest is protecting your data as it resides on disk. So if anybody takes your hard drive out of your data center, they still won't be able to read the data because it's protected. They won't have the key. Finally, now that you have all these bells and whistles enabled, you still need to be able to audit the data. So how do you know that just because somebody doesn't have access to data, they haven't accessed the data, right? So this is where Cigna has enabled Cloudera Navigator to audit every access to data. So every time somebody looks at the file, every time somebody writes file, somebody sends a SQL query, all of that information is being audited by Cloudera Navigator and recorded. In addition to that, Cigna has integrated Cloudera Navigator into the existing SIEM tool. For those of you who don't know, SIEM is a system information management tool. So basically, all of the audit events go to the information security group, who can later audit them and kind of make sure everybody has been accessing the data properly. And all of those bells and whistles actually serve one purpose, multiple purposes, but one very important purpose is being able to segregate the user, so for multi-tenant environment use. Okay.
Yep, so Jeff mentioned multi-tenancy, and one of the other aspects of that, besides the security feature that Jeff was talking about, is we also wanted to make sure that people from various departments or application groups couldn't just get on the cluster and take over 100% of the cluster when other people required the same thing. So we assigned them to various pools using Active Directory groups, and we made sure that Department A can only use 30% of the cluster when Department B is also utilizing the cluster at the same time. So we made sure that different types of workloads are being handled by the same Hadoop cluster that was deployed. So this is just a high-level vision, and we'll dive into a more specific view of this. And no presentation is actually complete without some grotesque animation, so I made sure I put that in. So at the center of anything we do, obviously it's surrounded by our Hadoop cluster. And even though this says MapReduce, I left it in there because I did this three years ago. Now we've got Spark in there as well. We do Spark streaming, and some of the other features that Jeff was talking about. But at the center of anything we do is the Hadoop cluster. We submit our workloads through what's called a utility server or edge node type environment, where nobody actually physically gets on the cluster. We stay on the edges of it, and that's how the authentication authorization occurs. We submit all our jobs through the edge nodes. And all the clients also communicate to the Hadoop cluster through the edge nodes. Some clients will interact directly with the cluster, but even so, they go through the same security mechanisms that the edge servers do. So 3 years ago, we wanted to do real-time processing, and today, since last year, we actually started doing real-time data analytics. And what that really means for us is, when people are using our websites, how can we see that information as they're clicking through potentially, or they're encountering errors on our websites. How can we take that data, bring it live into our Hadoop cluster in real time, and also feed data that we then come up with through analytics back to a MongoDB, for instance, and then the websites can actually interact with that data as well. So we do have live data streams enabled now. We have the ability, obviously, to send curated, refined data from Hadoop to things like Teradata and Oracle if that's what the business use case defined. So we can push the data out to other RDBMSs or even file systems if that's what they preferred. And we also read from them, right? So we read from our RDBMSs, we bring data in to populate our data lake because we want to centralize all our data, whether it's just for BI, intended for BI, or even intended for other application use. So we've got SAS connected to our Hadoop cluster. We have Tableau connected to our Hadoop cluster. We have a product called Looker that allows you to do live, real-time sort of access to big data environments, so it could do passive or live. And so enabling analysis and BI tools is at the center of our architecture. And also, since we started with a very small cluster, 16 nodes. Now we're at about 76. Hopefully by the end of this year, we could even hit 100 nodes in our production environment. So before I jump into some other things, I wanted to just sort of take a minute and talk about Lambda architecture. It's at the center of anything we do, right? So what we want to have is some guiding principles, and we took from the Lambda architecture, and Nathan Mars was actually writing this book when we were actually taking from what he was trying to tell us about Lambda architecture. What we wanted to do was make sure that we had a master data set. It was immutable. Today, things are different. Today, we have Kudu because we've realized over time that you just can't have anything that's just immutable. People want to send you transactions. People want to update the data. And HBase will cut it, but not most of the time. So if you've been to the Kudu talk, you'll know that in a real-time environment, Kudu is going to play a very big part for us in the future as well. So we're looking forward to using it as soon as it gets out of beta. And so from a serving layer point of view, what we try to do with Lambda architecture is, as the data comes in, create many views for many users, right? But when the data arrives in batch, you may be missing out on data that's currently arriving, which is what we take care of through our Kafka layer, which is our speed layer, as indicated by the Lambda architecture. So we employ some of the features of the Lambda architecture to always make sure that when a business person or an IT person or an application wants to look at the data, if their use case wants it, they should get the full picture of the data. So a Lambda architecture tells you that we should have a general system, which is what we do. We make sure any type of workload, any type of use case is supported by the system, right? So whether it's exploration, whether it's analytics, or whether it's running real-time analytics, any type of use case is supported by the general system. It's also an extensible system, so when we have features like Impala or additions are made to Impala or Kudu is added, we want to make sure that we take advantage of them, and we do, and nothing really changes because underneath all of that is still our data still lives in HDFS, and now we're just employing new things that were added to the platform. It's a debuggable system where anything that happens, and Cloudera gives us this, is we can look at our logs, figure out what's occurring in the environment, and being able to debug. Minimal maintenance here actually means that if the data is ever corrupt, can we fix it? And we can, because we just re-ingest it from the sources, or we recreate it by running our processes again, so we can remove the errors in the data, right? There's of course common SDLC practices that you follow, not to deploy models that constantly introduce errors in your data, but you can always fix them by rerunning them. And the exploratory capabilities I already talked about. HDFS gives us robustness and fault tolerance, and HBase or the speed layer will give us low latency and update capabilities. And obviously the Hadoop environment is scalable. So we put Lambda architecture on top of anything we do. So just take a quick brief timeout, right? So when we were going through our journey, I wanted to sort of lay out some of the most common misconceptions that people wanted to employ Hadoop for that arose. And one of them was, hey, can we just use this Hadoop platform for ETL or ELT? Well, you can, but what we also want to do is take that data and allow you to do analytics on it, right? So we wanted to make sure we were constantly evangelizing. So as part of the 3-year process, education was the biggest thing. You always go out and talk to people and you tell them, yes, you can use it for ETL. Yeah, we can help you move the data too, but why don't you leave your data in the Hadoop platform so you can actually do analytics on it? So, and the other thing is, you just can't put your data there and use it as a storage system, right? Hadoop's not a storage system. You want to take full advantage of all the features that Jeff was talking about. So the biggest challenge we had was whenever we wanted to bring data into our lake, the people who own the data always said, it's mine. You can't touch it, it's my data, what are you going to do to it? So Our promise was always, we're not changing it, we're just bringing it over, we're going to make it available for analytics. Again, it was evangelizing the fact that your data, if it's precious, will not be changed. And your data, if it's restricted, will not be given to people or applications. The security features that Jeff was talking about. We'll have all of that in place. We can do masking. We can create many different forms of the data. Your data will be safe. We continue to deal with a lot of that today, but it's something that we've gotten much better at. So sometimes it takes a long time to bring the data in, and a lot of that has to do with that previous challenge. So in general, the biggest message we came forward with was Hadoop's a complementary platform. It could potentially replace everything, but we don't want to do that. We want to introduce it as a complementary platform, and then we want to see where it takes us. So that's where we left it, right? So in the end, we introduced a lot of things, right? The biggest thing that we evangelized was the fact that what you have is a data lake. So data lake, you can Wikipedia it. Data lake is many things to many people, but to us, data lakes is two major things, right? You can put all your data in the Hadoop platform, but now you have the advantage of a very large cluster, and you have the advantage of a compute power. So it's data and compute power. Those two things combined is what data lake means to us. And essentially, Martin Fowler actually, so I stole this from Martin Fowler, he actually does a good job of explaining the two if people like pictures, right? So whereas you have one consistent schema in a warehouse, on the Hadoop side, I can have many schemas for many users and many use cases. So I have the ability to create what you want on the fly and assign metadata to the same data and create it in many different shapes, right? So Martin Fowler did a good job of that, and so I don't have to say anything else about that. So one of the other factors that we wanted to do with the data lake is once the data is in the lake, how do you process it? So this picture has many different aspects to it. Top down, there is at the top, on the top of it, you have a lot of web app type access. So how do web applications get access to the data? At the bottom, we have, well, how do tools like SAS or Tableau get access to the data? Or what if people just want to run our programs? On the left side is how does data come in, right? It can come in batch, or it can come in real time. And I'll go over Kafka and Spark streaming briefly in the next few slides. But what you're actually looking at is there's also ETL in place. So what we do today is if I ingest an XML document, it goes through our Kite SDK or Morphlines pipeline, and we assign it a map, and we say, take the claim, split it up, and give it some structure. Or it could be any XML document. I don't want people to use XML, but they still do. But the same pipeline you can send JSON objects over it. So there is ETL, ELT that we can do on the Hadoop platform as well using a lot of the open source, and Cloudera allows us to deploy a lot of those things on the platform since they include Morphlines and the Kite SDK in their distribution. We also run a different version of Spark in our Hadoop clusters. So even though the most current version supports 1.5, right? Yes. We actually build our own 1.61, and a lot of our Spark streaming and Spark code actually runs using that. So we're able to extend it without anybody knowing it. So data arrives many different ways, batch, real time. The Hadoop engine that we have in place processes the data, creates as many views as you want, or the data is just living there for people to come and explore. So we have data scientists, that little guy sitting in the corner over there, and they can run R or SAS on it, right? So they can just explore the data live. So that's the general system allowing people to do whatever they want it to do. And we could also push data out once it's curated and refined to other RDBMSs, NoSQL data stores, or even Teradata. So Hadoop and Teradata make up our sort of big data ecosystem, but the ecosystem isn't complete without query federation, right? So what if people didn't care where the data lived and they just wanted to query, just wanted to write a query, whether it's in Teradata or Hadoop? We federate that as well. So we allow them to hit both sources and get the data that they want potentially for reporting. We also have microservices. So I don't have a lot of detail on how we do microservices, but it's essentially just small little functional services that sit on top of the data. We have monolithic JSON over HTTP services too that allow you to retrieve data directly from HBase and Hive. And as the data is returned, you get JSON over HTTP. So one key thing to watch out for is if you're hitting a table that has 1 billion records, you can't write a service that says return me 1 billion records. So there are caps that we assign internally to our systems to make sure that the data isn't returned or crash the system that's asking for it. So quickly into the real-time aspect of this, I talked about Kafka and Spark streaming in the previous picture. We actually have use cases where if a person clicks on a page on a website, and there was a problem and they call us, I want to know about it before they do. So we put in Kafka and Spark Streaming in the mix to detect a lot of these changes. And there's a really cool slide that I'm going to go by. It's cool for me, I don't know about you guys. So from a Kafka point of view, what are the benefits it's giving us? Well, it completes Lambda architecture for us, right? It says, I'm going to give you data that's coming in now, and I'm going to give you access to data in the past, and now you have all of the data in the same place. Kafka is a high throughput, low latency data pipeline for us. We call it our event fabric. So anything we do now asynchronously, whether it's interacting with the Hadoop cluster or data coming in from the outside, we just dump it on Kafka, and people subscribe to it as if they want, or even one of our Hadoop is a subscriber for Kafka as well. So it sits and listens for events, and data just gets into HDFS where we can do historical analytics on it. So besides Kafka, we also wanted a quick micro batch type of an environment. And for 90%, in my opinion, for 90% of the things people want to do, Spark Streaming will actually serve the purpose, right? You don't have to use Storm or even Akka streams. You can actually just use Spark Streaming for most of the use cases that come your way and batch things up in 1 second or 5 second intervals, and that's what we do. And Jeff talked about Spark Core, and if you attended some of the talks on Spark, the key 3 areas that we like about Spark are in-memory data processing. It has rich APIs, so we have developers who write in Python. We have developers who use Scala and Java, and the same API, you can use any different programming languages on it, right? So, and it also supports batch and real time. So those main key areas actually allows us to shift a lot of our MapReduce work onto Spark, but we still use MapReduce heavily because there are some very extreme scale data jobs that we run that Spark today, we'd have to scale out quite a bit to be able to support. So our real-time architecture really breaks down into three key categories, right? You have producers of data, you have consumers of data, and then there's some processing magic that happens in the middle. And so one of the use cases, and there's like many different use cases, Kafka solves a lot of different problems for many different applications and use cases. One of the ones that I just want to talk about briefly is if a person clicks on many pages, so think about 1 million people going on a website, clicking on many different things, we can collect those events into Kafka. You can use Flume if the tools that are employed on your websites don't support directly writing to Kafka, even though it would be awesome if they could. You can just use Flume to bring the data into Kafka, which is what we do in one of the cases, and data just sits on Kafka for somebody to subscribe to it and process it. You can use things like Oracle Golden Gate to send as data changes on your databases directly to Kafka as well. From the processing point of view, what we did, and Jeff and I, shameless plug, Jeff and I wrote a blog on this, how do you tune your Spark Streaming app if it's gonna store in memory a table that has 125 million records in it. And so we had a really fun time doing that. So in this case, what happens is a message is picked off of Kafka, Spark Streaming gets it, Spark Streaming then looks at that event that occurred on our website and says, who is this? And it scans 125 million records to figure out in memory, to figure out who was it that clicked. And it enriches the data and does a little bit of slight analytics on it. And then it could write it back to Kafka, but in our case, we actually send it to the top box there for Hadoop so we can actually do some more analytics on that data. Once the data lives in Hadoop or it's in Kafka, you can actually have microservices that just read off of Kafka and Hadoop. In our case, it's off of Hadoop today, but we're going to shift it to Kafka soon and deliver that data to call center web apps, for instance. And they could actually see what occurred on the website before the person calls. Or they can query it live to see when the person calls, what is it that they do. So within seconds, the round trip for us is about 10 seconds for various different reasons from click to availability on the call center desktop. So it's near real time. We're trying to make it fast as time passes, but this is just a high level representation of what I just talked about, where we're actually taking data from another store and we're just loading it in memory to a 24/7 Spark Streaming job, which is, by the way, running as a Cloudera service. So it's available in Cloudera Manager, and you can actually see it if you guys are customers of Cloudera. You can actually see the service running in Cloudera and monitor it live. This is just some detail on the blog that we wrote. When we first started, the end-to-end trip that I just told you takes a few seconds used to take 8 minutes. And that was because we loaded too much data into our Spark app. And so through the magic of some tuning parameters and upgrading to more recent versions of Spark and using data frames, we actually got it down to just a few milliseconds, and the whole trip takes about 10 seconds. The secret to how the data is fast is we work with compressed data with Parquet. So anything we do is stored on our Hadoop cluster using Parquet. And if you guys don't know Parquet, it's a columnar storage format, gives you excellent compression with Snappy. So if it's, for instance, 4 terabytes of data, we can compress it down to 250 gigabytes. So we get, much more bang for the buck for our storage space on the HDFS on the Hadoop side. So from round trip, when the data comes in, scanning 125 million records and sending it to the desktop within a few seconds was pretty good for us, right? And so now we're scaling it out and making sure that when the data comes in, clickstream data comes into Kafka, Spark streaming is faster and faster. So what we've done is we broke the part where Spark actually writes to Hive directly using Spark SQL. What we do is data comes into Kafka, one Spark streaming app 24/7 picks it up, enriches it, and writes it back to Kafka. And another Spark streaming app picks it up when the event shows up within a few milliseconds. And now we can write to HBase, Hive, hopefully in the future Kudu. If you were in a talk this morning, they talked about Kafka to Kudu and how you can actually update and store update transactions in Kudu as well. So that's big for us. We're using HBase today to support update transactions, but really what we should be using is something like Kudu or Cassandra to be able to let us do that. But so that's pretty cool. So I'll just, if you give me a few minutes, I'll get on my soapbox a little bit. So we talked about data in Hadoop and how everything should live in the in the data lake. The biggest reason behind that is what's noise to you from a data point of view could be valuable to somebody else. So our goal is to democratize that data on the Hadoop cluster. So when I have discovered new insights, I can share it with everybody. When I'm looking at some data that I've never had access to before, I can share it with somebody and allow others to discover new gems in that data. That was a really important culture change for us, which we're still going through. And one other aspect is we made the switch 3 years ago to make functional programming a big aspect for us. So because we do Python and Scala, what it allows us to do with data sets is we no longer store object models in our code. So you don't have brittle Java code with object models in them. What we do is we create the object in the table, so that's where your model is preserved, because I can create hundreds of them for applications. I can denormalize them, I can normalize them, but the model lives in Hadoop. And what I use Scala and Python for is actually creating behaviors and collections, and the same data, I can assign many different behaviors to it. So functional programming within a few lines of code, I can actually write pretty cool analytics using MLlib or other libraries that you want to use on the Python side as well. And that's what we're doing with both Python and Scala today. So Jeff talked about security, right? So one of the first things Luke Skywalker did is when he was given the most powerful thing in the galaxy, he pointed it at his face. And so what we're trying to do is not do the same thing. We're a healthcare company, and data privacy and HIPAA rules are very important to us. So even though I said we want to democratize the data, it has its limits. So what we do is it's masked. If you're not allowed to see that data, we use Sentry and other features to restrict data access. So it's all still there. The governance is still in place because you don't want your data lake to turn into a data swamp. So we want to make sure that people will trust what's in the lake. And when we implement the security features, we actually evangelize them to make sure people know that we're creating data that's both governed and has quality. So a lot of what we do from a development point of view also uses continuous integration, continuous deployment techniques, and there are tests that run on the fly as we deploy our code to the Hadoop cluster to make sure all of the stuff that's going to run on the Hadoop cluster has been quality checked. So the data that's created is reliable. And with that, we'll take some questions if you have them.
If anyone has any questions, just come up to the microphone, please, so everyone can hear. Thanks. One more.
So do you guys use Impala as well?
Yes, we do. We have various use cases for Impala. From an exploration point of view, we allow people to use Impala through Hue. We allow people to use Impala through SAS as well. and Tableau connects using Impala. But it doesn't fit all of the use cases because Impala is mostly in-memory processing. So in some cases, we use Hive adapters as well. So, but Impala is used.
I think you guys also use Impala, right? Which is
Impala,
a Python interface to Impala.
Yeah. So we have a framework that we wrote called IBIS, which generates these workflows, not to be confused with Cloudera's IBIS. They stole that name. That's what we think. But so we allow them to figure out if they use Impala to be able to connect from Python code. So we do a lot of your connection pool management and things on the Impala side and allow them to.
So you have a separate Spark cluster versus separate Impala cluster, or is
No,
it
it's
like
all in the same,
okay.
but we do things through pool management, which is the multi-tenancy thing that we were talking about, where we make sure Impala doesn't take more than 60% of the cluster if people have runaway queries, because we do allow for exploration. And so during the day, people could submit queries. And if they're not explaining their queries right, it could take over the cluster. So that's how we manage it today.
Okay. Thank you.
Thank you.
You mentioned federation of queries between your Teradata environment and your Hadoop environment. What types of technologies and infrastructures are involved in that federation?
Well, I think there's a few different vendors out there. We're actually using Cero to be able to do query federation. There's Red Hat that does a lot of data virtualization, but that's much bigger. So we're just looking at how to, at least for now, enable sort of like without people having to specify JDBC URLs and things like that, just use something like a Cero to federate between Teradata, Hadoop, and Oracle, for instance. That's what we use today for federation.
Thank you.
Thanks.
So 2 questions. The first one is, how does your workflow from those updates flowing to HBase get back into your Parquet files for Impala Hive? And then in the future for Kudu, do you see it replacing both of those, or are you still going to have HBase and/or Hive/Impala?
So our use case, the reason why we went to HBase is because there's interaction data that comes in where it's updating potentially the same record. And as you know, we can't do that in Hive. So we switched to HBase to support that. So once the data is in HBase and people want to use it, we have Hive metadata sitting on top of it so they can use Hive to query it. So it doesn't land back into the same stores. The data is only kept once. In the future, our goal is to just, for this particular use case, not use HBase at all and use Kudu and speed this up, because we go from data coming in to Kafka to Spark streaming to HBase. What we want to do is go from data coming into Kafka to Kudu directly. And if we wanted to duplicate it, we would also place it in HDFS.
So why can't Kafka just write directly into HBase? What are you doing in Spark streaming that?
It needs to enrich the data that's coming in.
Okay.
And if we just wanted to store it, it can go directly, yes.
Okay, so but
In this particular use case.
how would Kudu not require enrichment?
It would still have Spark streaming.
Okay.
I'm just saying it won't go through there's some other layers that we have to go through to get the data to HDFS. I'm sorry, to HBase. In the case of Kudu, we would not use NoSQL, right? We would actually employ the SQL features of Kudu. So it actually, most of our use cases, people are comfortable with using SQL rather than NoSQL. So that's the other thing with HBase is we want to get away from and just use something like a Kudu to do that.
Okay, so I guess last one really
Yeah,
quick.
sure.
Have you evaluated Trafodian and those other kind of SQL on HBase?
No, we have not.
Okay.
We simply just use what was available on the platform.
Okay.
Yeah. We're just looking forward to Kudu.
And last question.
2 questions? Yeah. I have 2 questions basically. So one is about the security, right? So the security, the different aspects of the security, like you have the authentication, authorization, and of course encryption. Authentication. So are you using the Cloudera supported? Is the Cloudera is giving something, or you build something for the authentic? Because you mentioned that you're using the multi-tenancy.
For
Data storage, right? So in
Yeah.
the data lake, basically, I'm interested in data lake. How do you provide the security?
Jeff can step in, but we actually use Kerberos to do authentication. So everything is
Kerberos,
based
okay.
off of a local KDC that interacts with Active Directory today.
Okay, so the directory is directly on the HDFS directory.
Behind the
path.
scenes is Active Directory.
Yeah, the way it works, Active Directory has a one-way trust to local KDC that Cigna is running. So all of the users, all of the groups and everything gets pushed down to Linux file system. So yeah, I mean, that's how it's working today.
Okay, so you basically categorize or segregate the data based on the groups, Unix, Linux groups,
Yeah.
POSIX groups.
Yeah, it's
That's how you
Active
store?
Directory, Active Directory groups.
Active Directory groups.
Yeah,
Okay.
there are some
Active Directory groups that get
Down to Linux.
propagated to Linux. Yeah.
Linux. Okay.
yeah, behind the
Okay.
scenes. It's like SSD or Winbind that does that for us.
Yeah.
Okay. Thank you. So the other question is the continuous integration.
Okay.
So what tool you use for the continuous integration and continuous deployments?
So we have Jenkins.
Oh, Jenkins.
Yep,
Okay.
to build our code, and then we have something called udeploy that connects the dots together and just goes from environment to environment. And then we have test cases that run. So as test cases fail, we don't move the code from our dev instance to our integration instance, for instance. So they're both running in the background. But for Python, we use a combination of different tools that are scripted together. And for Scala, it's different things. So if you went to Holden Karov's talk, we actually use Scala check in the background and Scala test to do a lot of those tests. So Jenkins will run them for us. It does code coverage. It makes sure you have test cases for most of your code. We have a threshold set, and then as the tests pass or fail, we figure out what the threshold for that is. Every use case is different, but it progresses through the environments using scripts in Jenkins.
Scripts and Jenkins. Okay. Thank you.
Let's thank our speakers.
Thank you.